start the question part of the STEM part of chapter 11, current electricity. So in this part, we'll be seeing the mostly circuit related problems, the problems which you'll be given this sort of circuits and be solving problems according to the given circuits. Okay, so first of all, they are asking us to find out the equivalent resistance of the circuit. So how to find out the equivalent resistance? We know that either the resistance can be in parallel or it can be in series. So first of all, we need to see that which of these resistances are in series and which of these are in parallel. Okay, so let's do that. So this is in a series and this is in parallel. Four and 12 ohm are in parallel. See, parallel connection. These two resistors are in parallel connection. Okay. So we know the formula that to find out the equivalent resistance, we know this formula that 1 by Rp is equal to 1 by 4 plus 1 by 12. So this 12, 3 plus 1 is equal to 4 by 12, and reversing this, Rp is equal to 12 divided by 4, which is equal to 3 ohm. So the resistances which are in parallel, their equivalent resistance or Rp is equal to 3 ohm, and there is a resistance which is in series which is 6 ohm. Now let's find out the equivalent resistance for this whole circuit. Plus 6 ohm. 6 ohm was in series, so 3 plus 6 is equal to 9 ohm. So the equivalent resistance is 9 ohm, and this is it. This is the equivalent resistance of the circuit. Okay, so the next one. The next question they are asking, if all the series in the stem are connected in parallel, will the fuse be burned for the produced electricity? Now, if these two are in parallel, 4 and 12, these are two parallel, and 6 is in series. Now, what if these three are in parallel? In that case, we're going to check whether the fuse will be burned for the produced electricity. So first of all, let's assume that all these three resistors are in parallel connection, and then we find the equivalent resistance, and then we are going to check that whether the current which will be produced by keeping this resistance in parallel connection will cause the electric fuse to go off. So R1 is equal to 6, R2 is equal to 12, R3 is equal to 4. Okay, so we are assuming that all these three resistors are in parallel connection. So if these are in parallel connection, then what is the equivalent resistance? Is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So R1 is equal to 6, so 1 by 6 plus 1 by 12 plus 1 by 4. So 12, this is 2, 1 plus 3, which is equal to 1 by Rp is equal to 2 plus 1, 3, 3 plus 3, 6, 6 by 12, or you can write Rp is equal to 12 divided by 6, 2. So Rp is equal to 2 ohm. So if all these three resistances are connected in parallel series, then in parallel connection, then the amount of resistance we are getting is 2 ohm. Okay, so now we have to check that whether the fuse will be burnt because of the produced electricity. So for that we will be using I is equal to E by Rp. This is the same formula that we have learned in theory section, that to find out current we need to divide this resistance from the potential that is given, which is 12. So 12 divided by 2, how much we are getting? 6. We are getting 6 ampere of current. So the fuse will remain intact because the current which is being created is I. Suppose this is we are calling this I prime. So I prime is greater than the given I, which was 2. Okay, so it will flow through the fuse.